Alright, here's a screencast on a couple examples from homework on 9.2, which is multiplying polynomials. Your acronym that you need to remember, and it should be placed at the top, is FOIL. FOIL stands for first, outside, inside, and last. So we're going to go ahead and put that as a big heading right here on our sheet. And if you have not done that yet, you might want to put that on your work. First, outside, inside, and last. Now, FOIL will work on most, but it will not work on all because some of these are special situations. Hopefully you're not writing this right in the middle of your name like I am, but hopefully you have more room to put that somewhere up here. Now this implies on situations where we have a binomial, which means two terms, multiplying with another binomial, which is two more terms. Okay? So let's go over the example on 8 to talk about FOIL. The first terms here would be 2m and m. So these are my first terms that multiply. And if I multiplied 2m times m, the result would be 2m, and now it goes to the exponent of 2. So 2m squared. Now my outside terms, they speak in terms of from the center out. So the outermost terms would be 2m and positive 3. And when I multiply 2m times positive 3, I get a result of 6m. 6m. 2 times 3 is 6. There's only one m in that multiplication process, so that's the result. Now we need to go to the inside terms, and once again we're talking from the center, working our way out. So the inside terms would be these two terms here, and 1 times m would just be a positive 1m. And then the last terms to multiply are the last terms in the parentheses, and that would be 1 times 3. And 1 times 3 would give a result of 3. Positive 3. Okay? At this point, it looks like we've gone through the FOIL process, so we should be done. But we do still have one final operation here. We need to combine like terms. So after we FOIL, make sure we combine all like terms. Okay? When we combine all like terms, the like terms we have here are 6m and 1m. When those combine, our result is 7m. That's your full-on answer for number 8. Okay, my first hour working with us today has a question on a certain problem. So we're going to jump down to that problem, and we're going to take a look at it. That problem happens to be number 14. Now, number 14 is one of those situations where FOIL does not work because there are multiple terms. So let's jump in to number 14, and let's figure this one out. Okay, we're going to start off with this first term. And we recall that the multiplication of polynomials is very similar to the distributive property. So we have to distribute this first term to all three terms in the other polynomial. So m times m squared would be m to the third. M to the third. M times negative 2m, it's going to be a positive times a negative, so it's negative 2m to the second. 2m to the second. And then when we multiply m times positive 3, that's a positive times a positive, which is a positive what? 3m. Now that we've gone through that first term, I'll change colors so you can see the second term. And the second term that's going to multiply is the negative 2. And once again, it must distribute to every term inside the other polynomial. So we're going to multiply negative 2 times m squared. That's a negative times a positive equals a negative. And the result is?
Negative m to or negative 2m to the second.
Good. Negative 2m to the second power. When we multiply the second one, it's negative 2 times negative 2m. That's negative times negative. It's going to be positive 4m. And then we take negative 2 times positive 3. Negative times positive is negative 6. Now at this point, after we've done that distributive process, and we've got all terms multiplied, we combine like terms. Should be on the bottom. So when we combine the like terms, m cubed does not have any other like terms. So I'm going to bring that down because that has the highest value of exponents. It has the highest degree of exponents. That must be my leading one. After the exponent of 3 comes the exponent of 2. Here's one that has an exponent of 2. Here's another that has an exponent of 2. When I combine them, what do they equal?
0.
If this were positive, it would.
Negative 4m squared.
Negative 4m squared. After the degree of 2, we go to the degree of 1, which would be the m's here. So positive 3m
7.
plus 4m is 7m. And then this one has no exponent attached as far as the variables go, so it's just minus 6. And this is as good as number 14 gets.
What about number 7?
Hey, I have a question just on number 13. When you take w times 2w, is that...
That would be w to the power of 3. Because that's w times w squared, which is ww.
So if w to the third plus w to the third, what do you get that?
There should only be one w to the third. That would be your first terms multiplied.
Well, if you put w
It's double u.
arrow to w2, then what's that?
That would be w times w squared, which is w to the third. But when you go to the next term, it would be w times 2w, which would be 2w squared. Okay? We'll talk about that one a little bit later on. All right, we had one more that we wanted to set up, look at. So let's jump down to one of those ones on the back. Do we want to go 19 or 20?
I still want to do 7.
We'll jump back to that later. All right, let's talk about 20. Number 20. How do we find area of a rectangle? We multiply what times what? Length times width. So I got to do length times width here. 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 And if I'm finding the area of the whole shaded region, what am I going to have to do to each of these rectangles' areas? If I need to find the total area of all of this,
I think it's 2.
if I take length times width, length times width, length times width, length times width, how am I going to have to combine them? I'm going to have to just add them up. All right? So let's start in the bottom left corner. What is its length?
2.
2. What is its width? X. So that's one of my rectangles. Let's go up to the top left corner. What is this one's length? X. What is its width? There's a second rectangle. Now what are we going to do with these rectangles as we go? Add them up. Alright? So let's go ahead and move to the bottom right. What's this one's length? 2 times 4. And what do we do with the rectangles? Perfect. And let's go ahead and do the last one. What times what? X times 4. And lastly, we're going to add those. So let's go ahead and multiply here, 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 and here. What's the first one equal? 2x plus x squared plus 8 plus 4x. As we write these, let's start to put them in order. So what is the leading term? X squared.
Plus 6x.
Plus 6x.
Plus 8.
Plus 8. Okay, that's going to close out this screencast. We've given a few examples. My first hour may go over more, but for now, that's it.